Let us resume engineering mechanics problem set 2.7. A little lengthy one, but still it is easy to understand. The ends of a heavy prismatic bar. AB is a prismatic bar, means all throughout the cross section of the bar is same. If this is the bar, the cross section here all throughout is same. The bar are supported by a circular ring. This is a circular ring in a vertical plane. The circular ring is in a vertical plane. The circular ring is not horizontal, is like this, is vertical, and the prismatic bar is supported. If the length of the bar is such that it subtends an angle 90 degree in the ring, this end of the bar and this end of the bar at point O, this subtend 90 degree, and the angle of friction at A and B, angle of friction is phi. Now, what is the greatest angle of inclination theta that the bar can make with the horizontal in condition of equilibrium? Now, what is given? Given angle AOB, this angle is 90 degree, and since AO is equal to BO, that is the radius of the circular ring, therefore in triangle OABO, AO is equal to BO being the radius. Therefore, these two angles will be equal. Therefore, this angle will be 45 and this angle will also be 45 degree. Now, let RA is the reaction force at A, RB is the reaction force at B. So, RA, the reaction force at A will be pointing towards O, normal reaction, normal to this is surface at the point of contact A due to some action force. Similarly, RB is the reaction force at B pointing towards O, let it be RB, and this RB is normal to this surface at point B, at the point of contact. Now, therefore, RA and RB both pass through the point O, the center of the ring, which is ring is in a vertical plane and the prismatic bar is supported in it. Therefore, RA and RB both pass through O. RA and RB both make 45 degree with bar AB. This is 45, this is 45. This is because angle AOB is isosceles triangle where the sides AO is equal to side BO. Now, let FA, capital FA is the force of friction at point A, capital FB is the force of friction at point B. Let me explain you what will be the direction of the force of frictions FA and FB. If the end A, this end of the bar is sliding down, means the situation is like this. If this bar is sliding down, then the point B, the point of contact B will move up. So, if the end A is sliding down, the end B will tend to slide up. So, the direction of force of friction at A and B will be as shown in the figure here. A trying to move to this way, here the force of friction will be to this side, and here the force of friction will be to this side. And force of friction FA and FB is perpendicular. FA will be perpendicular to the reaction force RA, FB will be perpendicular to the reaction force RB. Now, so that is I have shown here. This is the center of the ring, the prismatic bar AB. This is from the center of the prismatic bar, the weight is hanging vertically downward. This angle is given as theta. This I just explained you how this is 45, and this angle also explained how it is 45. RA is pointing towards O, RB is also pointing towards O. Now, now, now in this triangle, in this triangle, in this triangle and in this triangle, both are 90 here. This angle is vertically opposite to this. So the remaining angle, so since this is given as theta, therefore this will also be theta. And the direction of FA, here let me explain again, as point A is trying to slide down, as this prismatic bar is trying to slide down, and in this position it is maintaining equilibrium, here the direction of force will be to this side. That is what I have shown here. Similarly, at point P, the direction of the force of friction will be to this side. That is what I have shown here. Now, so the force of friction at point A is perpendicular to RA. So this whole is 90. This I have taken as y-axis. So this is 45, 45. This is because I have this taken as this is your x-axis. This is your y-axis. This whole is 90. 45 is gone from here. So I am left with 45. This F is perpendicular to RA. This is 45. Therefore, this is 45. So together they have to be 90 because FA is perpendicular to RA. Similarly, at the point of contact B, the force of friction FB is perpendicular to RB. So this whole angle from here to here is 90. This is I have already proved as 45. So this remaining one. So this remaining one will be 45. And so this remaining one will be 45. This remaining one will be 45, right? And out of which this is this angle is theta. Now, now let us consider x-axis along the prismatic bar and y-axis perpendicular to it. I have translated the forces, all the forces to point C. Look, from point C, W is acting vertically downward, let this point is C. And if you shift RA parallel to itself, like this, and show it at C, RA will be to this side and this angle will be 45. Similarly, if you shift RB parallel to itself and shift it towards point C, then this is your RB and this will be 45. FB, if you shift FB, the force of friction to this point, parallel like this, then FB you can show here, so this angle will be 45. Because here this angle was given as 45, was proved as 45, RB is perpendicular to FB, so this angle is 45. So when FB, the force of friction at the point of contact P, when shifted parallel to the point of C, this angle will be 45, which I have shown it here. Now, now RB and FA. Similarly, if you shift RB, the reaction force at B, like this, and bring it to the point C, if you bring RB by shifting it parallel to itself, RB can be shown here. So this is 45, so this will also be 45. That is what I have shown here. Similarly, FA, the force of friction at A, if you shift this force parallel to itself and show it at C, then force of friction at A will be also in the same direction, making this angle 45. So I have shown it here. So that is what we have shifted the different forces to the point C so that we can resolve them into their horizontal and vertical components. Now apply sigma x is equal to 0. Now sum of the forces along x-axis is 0. Now look at, let me explain one by one. W sine theta, this is your W, this is your W. So to this side will be W cos theta and to this side will be W sine theta. So W sine theta is along positive x-axis, W sine theta is along positive x-axis, Ra cos alpha is along positive x-axis. Look here, this is your Ra. If you drop a perpendicular, this part will be from here to here will be Ra sine 45. If you drop a perpendicular here, this part will be your Ra cos 45, that is along positive x-axis. So Ra cos 45 is along positive x-axis. Similarly, if you split Rb cos 45, this is your Rb. If you drop a perpendicular from here to here, will be R cos 45, that is along negative x-axis. If you drop a perpendicular here, from this point to this point will be Rb sine 45. Then mu times the normal reaction, so mu times Rb cos 45. Mu times Rb cos 45. This is your Rb. So mu times Rb cos 45 is along negative x-axis. Rb is to this side, Rb cos 45 is to this side. And because it is trying to slide down, so the force of friction, that is Rb cos 45 is along negative x-axis, the force of friction. Similarly, mu times Ra cos 45 along negative x-axis. So now apply sigma x is equal to 0. These two forces are in the same direction. I have kept in the left hand side, and these three forces are in the negative x-axis. So I have kept it on one side. Now bring this Ra cos 45 to the right hand side, keep it with this, and take cos 45 common. We are left with Rb minus Ra cos 45. And from these two terms, if you take mu common and put the value of cos 45 and cos 45, it becomes mu times Rb cos 45 plus Ra cos 45, that is 1 by root 2. Now put the value of cos 45, 1 by root 2, this remains same thing as this. Now you take 1 by root 2 common, you are left with Rb plus Ra. Now there is 1 by root 2 here, 1 by root 2 here. There are two different terms, so take 1 by root 2 common. So we are left with Rb minus Ra plus mu times Rb plus Ra. Now bring this root to the left hand side. So this becomes W root 2 sine theta is Rb minus Ra plus mu times Rb plus Ra. Make it equation 1. Now apply sigma of y is equal to 0. Now Rb sine 45. This is your Rb. If you drop a perpendicular, this length will be Rb sine 45 along positive y-axis. Ra sine 45. This is your Ra. If you drop a perpendicular, this length, that is same thing as this length, will be Ra sine 45. That is also along positive y-axis. Then mu Ra cos 45. Look at, this is Ra, mu times Ra cos 45 will be along your negative y-axis due to the force of friction, and that is balanced by W cos theta plus mu times Rb sine 45. W cos theta, that is to this side, and mu times Rb sine 45. mu times RB sine 45 is along a negative y-axis. So now let us put the values. Sine 45, cos 45, mu RA cos 45. Now bring this term to the left hand side. Mu RB sine 45 W cos theta remains as such. So now if you take 1 by root 2 common, we are left within the bracket as RB plus RA plus mu times RA minus mu times RB is W cos 45. Take this root 2 to this side, so this becomes W root 2 times cos theta is equal to RB plus RA plus mu times RA minus RB, make it equation 2. And we'll divide these two equations to find out tan theta. And before that, we need to take the moment of the different forces about point C. Now, let us take the moment about point C. Since the prismatic bar is in equilibrium, the clockwise moment is equal to the anti-clockwise moment. RB sine 45 is at this perpendicular distance from C. RB sine 45, RB, if you look here, RB is actually here. If you drop a perpendicular, this is your RB sine 45, and from the point C it is at a perpendicular distance CB. So this RB sine 45 will produce an anti-clockwise torque. So RB sine 45 into CB is anti-clockwise torque. That is should be balanced by a clockwise moment of the force. That is mu RB sine 45 times CB. Mu RB sine 45. This is your RB. Mu RB sine 45 will be to this side. And it is at what perpendicular distance? Equal to CB. Similarly, RA sine 45 is at a perpendicular distance AC. And mu RA sine 45 is at a perpendicular distance AC. Now, since C is the midpoint of the prismatic bar, therefore AC is equal to BC. So for AC here, I can substitute BC or CB. From B to C, same thing as from C to B. So the left hand side becomes RB sine 45 CB, mu times RB sine 45 CB plus RA sine 45. Instead of AC, I write CB, mu times RA sine 45. For AC, I write CB. Now, if you simplify this, if you take CB common on the left hand side and the right hand side, it cancels. So we are left with RB over root 2 is equal to mu times RB over root 2, RA over root 2 plus mu times RA over root 2. Now take 1 by root 2. So this also cancels. So we are left with RB is equal to, reaction force at B is equal to mu times RB plus RA plus mu times RA. Now bring this to the left hand side, take RB common 1 minus mu. From here if you take RA common is 1 plus mu. So your RA is equal to, this term comes to the left hand side, RB times 1 minus mu over 1 plus mu, make it equation 3. Now divide equation 1 by 2, which I derived in the previous page, just few minutes back. So divide equation 1 by 2. So this cancels, this becomes tan theta. And this was the right side of the equation 1. This was the right side of equation 2. Now put the value of RA here, RA here, RA here, RA here, that is this value. Now once you put that, then it is simplified. Now so tan theta becomes, by putting the value of RA and RA. Now tan theta remains as tan theta. Just take LCM here, here, and here, and here, and simplify. this comes out to be tan theta is equal to 1 plus mu minus 1 plus mu, plus 1 minus cancels, plus 1 minus mu plus 1 plus mu, mu cancels here. 1 plus mu plus 1 minus mu cancels here. So similarly here, 1 cancels here. Just take LCM. Just take LCM here, here and here. So tan theta is 2 mu plus 2 mu, that is 4 mu over 2 times 1 minus mu square. So 2 cancels. So I am left with 2 mu over 1 minus mu square is your tan theta. So this is your tan theta, and we know the coefficient of friction is also equal to the angle of friction, phi. This you have studied in your school days. Coefficient of friction that we know from your school days, tangent of the angle of friction is equal to mu. Also tangent of the angle of sliding, that is, or sliding or repose, is also same thing as the coefficient of friction. So mu is equal to tan phi from the laws of friction. So now substitute for mu here, tan phi, tan theta remains as tan theta, so 2 times tan phi over 1 minus tan square theta. This from trigonometry is tan of 2 phi, because tan of 2 theta is equal to 2 tan theta over 1 minus tan square theta. So take the inverse function, so your theta is equal to 2 times phi. So your theta is equal to 2 times phi. So means this is the minimum, this is the maximum value. So theta should be less than equal to 2 phi.